thing on? Looks like it is. All right, for those of you who can hear me, this is Mr. Dove. I'm at a snow base getting ready to make some pizzas for Popsicle over here, my penguin friend and his family. In order to do that, I'm going to need your help. We need to figure out how to split these pizzas into parts and how that is all related to fractions and mixed numbers. So let's get started. Now, if you're a teacher, feel free to make screenshots and copies of those to use for your students' notes. And if you're a student, then you can watch this video, enjoy it, learn from it, and do the practice problems as we go along. So let's begin with the question of what is a fraction in the first place. For many of you, this will be review. For some of you, it might be the first time you're seeing this. So a fraction is a number at the top of the fraction symbol divided by a number at the bottom of the fraction symbol. In this example, I use 3/4, where the number at the top is called the numerator, and the number at the bottom is called the denominator. So this fraction of 3/4 has a numerator of 3 and a denominator of 4. I'll show that over here on the left side of my screen. Then we figure out what does the numerator mean and what does the denominator mean. So the numerator, or top part of a fraction, the 3 in this example, represents the number of parts in that fraction, while the denominator, which is the 4 in this example, represents the size of each of those parts. Not a size of 4, but a size of 4 on the bottom of that fraction, which is actually 1/4. So to say this in a sentence that hopefully makes sense to some of you, 3/4 represents 3 parts that are each 1/4 in terms of their size. So let's take a look at what that would look like. So we go to where the circle, which represents one whole, is split into 4 parts so that each part is 1/4 in size. And then we have 3 of those parts that are each 1/4 in size. So now we have 1, 2, 3 parts, and each of those parts is 1/4 in size because the circle was split into 4 equal sized parts in the beginning. So 3/4 is a fraction which has 3 parts, and each of those parts is 1/4 in size. All right, so here we have a pizza that is split into 4 equal sized parts, or as equal as I can make it, you know. And so if we take one of these parts out, then what we have are 1, 2, 3 pieces of pizza that are each 1/4 in size. So that's the same as 3/4 of a pizza, where 3 is the numerator and 4 is the denominator. Next, I want to go over how are fractions and division related, using the example fraction that we just talked about. So a fraction actually shows the division of a numerator divided by a denominator. So in our example, 3/4 equals the numerator of 3 divided by the denominator of 4. That would be the same as a dividend of 3 in long division divided by a divisor of 4. And when you do the long division, and if you haven't learned that yet, your teacher can go over that with you, or you can look at what I did here. But the final answer or quotient to that problem would be 0.75. Some people will call that 0.75. The correct way of saying that in words for mathematicians would be 0 and 75 hundredths. So in other words, 3/4 equals 0.75, or 0 and 75 hundredths. All right, I got a joke for you all. What did the police officer say to the penguin? Freeze. So moving on, let's discuss what are the types of fractions. So one type would be called a proper fraction. That would be like our previous example of 3/4. In this, the numerator is smaller than the denominator, meaning the top part is not as large as the bottom part. So over here on the left side of the screen, I'll show you 3/4 again. That's 3 parts that are each 1/4 in size. And then that looks like that over there, and that is a proper fraction. The numerator is smaller than the denominator. Next, let's talk about an improper fraction, like 4/4 or 5/4. So in an improper fraction, the numerator is actually greater than the denominator, like 5 is larger than 4, or equal to the denominator, like 4 is equal to 4. So 4/4 also works as an improper fraction. It just doesn't feel right. It feels improper, if you will. So for an improper fraction, let's take a look at what that would actually look like. We'll start with our 4/4. So we have a numerator of 4 and a denominator of 4. And here is what that would look like. 4 parts that are each 1/4 in size. So that is considered improper. Now, if we change this up top from a 4 to a 5, that fraction is also improper as well. And so that would be the 4/4 in addition to 1 extra fourth. So besides being an improper fraction, that 5/4 could also be classified as our next type of number. That is called a mixed number. In this case, 5/4 is equal to 1 whole. If you look on this circle to the left, that whole circle is filled, and then 1/4 of another circle filled in. So in other words, 5/4 equals 1 whole and 1/4. So in a mixed number, a whole number is added to a fraction, just like you saw there. So your improper fractions can be converted to mixed numbers. And some improper fractions actually can be converted to whole numbers if the numerator divided by the denominator equals 1 whole number. So, for instance, 4 divided by 4 equals 1 whole, or 8/4 equals 2 whole, which is another version of a whole number. So those are the types of fractions: proper, improper, and then we also talk about mixed numbers, which combine whole numbers with fractions. So right here we have 3/4, which is a proper fraction. The numerator of 1, 2, 3 parts is less than, or smaller, than the denominator of 4. Now, if I were to put another fourth here, then we would have the improper fraction of 4/4, which is also equal to 1 whole, in this case 1 whole pizza. And then if I were to put another 1/4 of a piece, then I would have the improper fraction of 5/4, where we have 1, 2, 3, 4, 5 parts that are each 1/4 in size. And that is also equal to the mixed number of 1 whole and 1/4, or 1 1/4 of a pizza. So at this point you might be wondering, well, can you convert between the fractions, mixed numbers, and other numbers that you've learned about, like decimals? I call them decimals. Your teachers might call them decimal numbers or something else along those lines. And the answer to that question is yes, you can transform fractions into mixed numbers, or mixed numbers into decimals, or decimals into mixed numbers, or decimals into fractions, or between back and forth between fractions and decimals. All of that is possible, and I'm going to show you how. So on the left side, you see the first example visually, which is that the fraction of 7/4 is the same as the mixed number of 1 3/4. See how we have 7 parts that are each 1/4 in size? 1, 2, 3, 4, 5, 6, 7 parts that are each 1/4 in size. And that's also the same as 1 whole and 3/4. Now, how do we go and show that mathematically? Well, I have a chart here, and if you would like to, you could always pause the video and follow along. And this chart breaks it down into how, if you're given a fraction, you turn that into a mixed number and decimal, how if you're given a mixed number, you turn that into a fraction and decimal, and how if you're given a decimal, you turn that into a fraction and mixed number. So let's start with the first one, 7/4, which I've shown you on the other side. So for that, we start with the fraction 7/4. To turn that into a mixed number, there are 2 ways I can think of without using a calculator. One would be to take 7/4 and to convert that into its whole number form. So we would have the fraction 4/4 that gives us the whole number 1 whole, and then add that to whatever is left over. In this case, 7/4 is the same as 4/4 plus 3/4, and we'll get to this later as to why you keep the denominator the same. If you didn't know that ahead of time, you'll just have to trust me for right now. So we have 4/4, which is 1 whole, plus 3/4, right? Which is 1 whole and 3/4. So 7/4 equals 1 whole and 3/4. Or what you could do is you could take 7/4 and turn it into a division problem with the remainder. So we have the dividend of 7 underneath the long division sign divided by the divisor of 4. 4 goes into 7 one whole time without overshooting, because if you did 4 times 2, that would be 8, and that would overshoot the 7. Then 4 times 1 is 4. 7 minus 4 is 3, and that is your remainder. 1 remainder, 3 out of 4, which could be expressed as 1 whole, remainder 3 out of 4 possible. So 1 and 3/4. Those are equal. And then if you wanted to turn it into a decimal, similar to how you turned it into a mixed number in this step, what you would do is you would take your numerator and you would divide it by your denominator, but you would no longer be working with a remainder. You would just do 7 divided by 4 without the remainder. And so 4 goes into 7 one whole time. 4 times 1 is 4. 7 minus 4 is 3. Then I put a decimal there. I line it up in my quotient as well. My quotient's my final answer here. Then I drag down a place holding 0. 4 goes into 37 times without overshooting. 4 times 7 is 28. I can't do 0 minus 8, so I take 1 away from the 3 and make it a 2, add 10 to the 0 and make it a 10. 10 minus 8 is 2, 2 minus 2 is 0. We're still not done yet, so we bring down another 0. That's a place holding 0. 4 goes into 25 times. 4 times 5 is 20 exactly. 20 minus 20 is 0. And then your final answer is 1.75, or if you were to say it in words the way your teacher would probably want, 1 75 hundredths. So in other words, 7/4 is the same as 1 3/4 is the same as 1.75 or 1 75 hundredths. Now we're going to continue with the next number over, which is 7 8/10 expressed as a mixed number. So to turn that into a fraction, we start out with the mixed number 7 8/10. Then we turn 7 into something that can be added to 8/10. So it needs a denominator of 10, and we will talk more about that in the future in this video, about why that is. For right now, you're just going to have to trust me. And think to yourself, in terms of your math facts, what divided by 10 gives you 7 whole back? So you can pause the video and think for a few seconds if you need to. And you should get 70. So 70/10 plus 8/10 is the same as 7 whole plus 8/10. So 70 plus 8/10, that would equal 78/10. And like I said, we'll talk about why the denominator stays the same at a future point in this video. So 78/10 is that fraction that you would get. Okay? Now, later on, we'll talk about how this could actually be simplified into something else. And if you don't know what the word simplified means, I'll also go over that in this video. But for right now, let's just turn this into the fraction 78/10. And for those of you who already know how to simplify this fraction, since they're both even numbers, you could divide both top and bottom by 2. So now that we have that this mixed number of 7 8/10 is equal to the fraction of 78/10, which is an improper fraction, let's look and see what the mixed number would be as a decimal. So 7 8/10. There are 2 ways to turn this into a decimal that I can think of off the top of my head. You can use the fractional amount of 78/10. That's an improper fraction, where you do 78 divided by 10 and see what you get. Or you can do 8 divided by 10 in the mixed number and then add that to the whole number of 7. So for this, I'm going to show you both. So first, real quickly, we'll do 78 divided by 10. 10 goes into 7 0 times. 7 minus 0 is 7. Bring down the 8. 10 goes into 78 7 times without overshooting, right? Because 10 times 8 is 80 and that overshoots. So 10 times 7 is 70. 78 minus 70 is just 8, right? 8 minus 0 is 8. 7 minus 7 is nothing. And then I go over here and I line up my decimals. I put a placeholding 0 there and I bring it down. And 10 goes into 80 8 times exactly, which is 80. And 80 minus 80 is 0. So we have 7 and 8 tenths. And this 0 can be taken away if you want in the final answer. Also known as 7.8. So that would be dividing the numerator of my improper fraction by the denominator. You can also do this as 7 whole plus 8 divided by 10. So that would be 7 whole plus the answer of 8 divided by 10. So 10 goes into 8 0 times. 10 times 0 is 0. 8 minus 0 is 8. Then we have a decimal here and here. We put a placeholding 0 and bring that down. 10 goes into 80 8 whole times. 10 times 8 is 80. And then 80 minus 80 is nothing. So we have 7 plus 0 and 8 tenths, or 0.8. And so what you get there is 7 plus 0.8. If you can't do that in your head, you can think of it as 7 with the decimal point, and then 0.8, put a placeholding 0 here, and what you end up getting is 7 and 8 tenths. Ta-da! So there are actually more than one way to convert between some of these different numbers. Now you could also use a calculator if you have that available. Of course that makes things even easier, but it helps to know what you're doing when you're checking your work. And last on this page we have this number as a decimal, which we'd want to turn into a mixed number and fraction. So for this it's actually pretty easy to turn it into a mixed number. Just go ahead and say the word form of this number out loud. In 3, 2, 1. If you said 12 and 15 hundredths, then you are correct. And that's what it is as a mixed number. So for this, you say the word form, and then you write out what that looks like. And so that would be 12 and 15 hundredths. So if you were actually saying the word form and writing it out in words, then you write out the word 12, then the word and then 15 hundredths. But we are writing this as a mixed number. So 12 and 15 hundredths as a decimal equals 12 and 15 hundredths as a mixed number. Ta-da! And so you could also simplify that and turn it into much easier fraction to work with, and we'll talk about how you would simplify in the future. But for those of you who already know how to simplify, for this one you could divide the top and bottom of this fraction by 5, and so this would end up being the equivalent fraction of 3 over 20, or 3/20ths. So 12 and 15 hundredths equals 12 and 3/20ths. That is an idea for another part in this video. And then what would that look like as an improper fraction? Well, if you simplified it even further, then you could still do this trick just with the simplified version of the mixed number. We'll do it with the version that we are using here. So we have the mixed number of 12 and 15 hundredths. And so we need to add something to 15 hundredths. And like I said, I'll be going over this fairly soon, which is the idea that when you're adding fractions, the denominators need to be the same. So we need to have a fraction with the denominator of 100 to add to this 15 hundredths. And so 12 whole equals what over 100? Well, that would be 1200 over 100, or 1200 over 100. Right? You can cross out those zeros and you see how that's the same as 12 over 1. And then you add 15 to that, and you get this number over, to keep the denominator the same, 100, or 1215 over 100. Now, like I said, if you already know how to simplify before this video, then you can simplify before or after when you're dealing with dividing by 5, and then just make sure for this part that you would be turning your whole number of 12 into whatever you needed to add to the denominator that you had there. Okay. All right. Moving on. Please pay close attention because this next part's also pretty important. I want to talk about what are equivalent fractions. So equivalent fractions, look, the word equivalent sounds very similar to the word equal. And they actually happen to be two or more fractions that are equal to each other in terms of their overall amount. So you can figure out if fractions are equivalent by multiplying or dividing your numerator and your denominator by the same number. So we'll see what that looks like in a few examples that I have. So as you can see on the left side of your screen, I have two pictures. One picture is of 6/8. And I'll talk about the other picture in just a few seconds. So for 6/8, you can multiply the top part of your fraction, known as the numerator, by a number. And if you multiply the bottom part of your fraction, the denominator, by the same number, then you'll get a new fraction that is equal overall in terms of its amount, or what it represents, to your old fraction. So 6 times 2 is 12, and 8 times 2 is 16. So because we multiply the top and bottom by that same number, right, which technically times 2 over 2 is the same as times 1 whole, we get that 6/8 is equal to its equivalent fraction of 12/16. Now you can also divide your numerator and your denominator by the same number. So instead of multiplying them both by 2 or by 3 or by 4 or by 5, or you get the idea, we could also divide. In this case, I chose to divide by 2 for both the top and the bottom. Right? Dividing by 2 over 2 is the same as dividing by 1 whole, so it works out. 6 divided by 2 is 3, and 8 divided by 2 is 4. So that proves that the fraction of 6/8 is equal or equivalent to the fraction of 3/4 in terms of its amount. And that's what you see over here. That 6 parts that are each 1/8 in size equal 3 parts that are each 1/4 in size. Those are equivalent fractions. The numbers may be different, but they represent the same amount. You see how the same amount is in red? So, we've proved mathematically that 6/8 and 12/16 and then 6/8 and 3/4 are all equivalent fractions. They all are equal to each other. Now you might be wondering real quick, how could I get from 3/4 to 12/16? Well, you just multiply the top by 4 and the bottom by 4. 3 times 4 is 12, and 4 times 4 is 16. Okay? Now, if you ever have to find out if a bunch of fractions are equivalent to each other and you have a short amount of time, then you would do what's called simplifying to all of them. And that's what I'm going to talk about in 3, 2, 1. So we get to the question, what is simplifying? Well, simplifying is turning a fraction into an equivalent fraction, or a fraction that's equal to it. That is in what's called a simpler form. How would you simplify? Well, you would do this by dividing both your numerator and your denominator by the largest whole number that goes into both the numerator and the denominator. That number, the largest whole number that goes into both of them, is sometimes called the greatest common factor of the numerator and the denominator, also known as the GCF. And I know it sounds complicated, but it's actually not too bad. For example, let's say we were dealing with the fraction of 9/12. You would figure out, using your knowledge of math facts, what the largest whole number would be that goes into both 9 and 12. Well, when I think about it, right, 1 goes into both 9 and 12, but let's see if something larger goes into both. Well, 2 goes into 12, but not 9. 3 goes into both 9 and 12, right? 3 times 3 is 9, and 3 times 4 is 12. 4 goes into 12, but not 9. 5 doesn't go into either. 6 goes into 12, but not 9. 7 doesn't go into either. 8 doesn't go into either. 9 goes into 9, but not 12. 10 doesn't go into either. 11 doesn't go into either. And 12 goes into 12, but not 9. So 3 actually is the largest number that goes into both 9 and 12. So it's known as the greatest common factor, or GCF, of both of them. Then what we end up doing is we take that greatest common factor, the largest number that goes into both our numerator and denominator, and we divide them both by that number on top and bottom. So we have 9 divided by 3 here gives us 3 whole. And 12 divided by 3 here gives us 4 whole. And remember, these are parts of a fraction, so our final answer is a fractional amount of 3 over 4, or a numerator of 3 divided by a denominator of 4, or 3 parts that are each 1/4 in size, or 3/4. So in other words, the simplified form of 9/12 is 3/4. It doesn't get any simpler than that, because there's nothing you can divide both 3 and 4 by to get whole numbers back on top and bottom except the number 1. And that would just get you 3 divided by 1 is 3 back, 4 divided by 1 is 4 back. So it just gets you back to your simplest form of 3/4. So when your teacher asks you to simplify, what they mean is see if there is a GCF, or greatest common factor, that goes into both your numerator and denominator, and if so, divide them both by that until you get to your simplest form. Or if you can't figure out what the greatest common factor is, and I think I'd said that recently, I may have mispronounced it a few seconds ago, then you could still try and figure out if any numbers go into both of these, and then just keep on dividing until you couldn't divide anymore. All right? Now this 3/4 represents the simplified version of 9/12, as you have seen. But if I wanted to turn this into its equivalent fraction of 9/12, I could simply split each of these 1 parts into 3 parts. And then if I did that with all of the parts of the whole, there would be parts that were each 1/12 in size, and then this would represent 9 of those 12 parts. Let's take a quick break and watch Popsicle find his family. So he's walking through. He obviously didn't need the walrus's help. He's going to ask this penguin. Alright, sounds like the penguin's sending him in another direction. So there he goes. Maybe he's got a friend close by. Oh, nope, he's going to bypass that one. Past the igloo too. Oh, it looks like there are a couple more penguins over there. That might be his family, actually. Oh, yep, that's his family. So he sees his brother and... yeah, I could see how that would happen. And now he's going to ask his mom about her pizza order. Next, let's talk about how do you add and subtract if the denominators are the same. And if the denominators are known as the same, then they are known as common denominators. So if you're trying to add or subtract fractions where the denominators are the same, then you keep the denominator the same, since the part size would need to be the same when you are adding or subtracting a certain number of parts. You do that to be fair for the whole thing. Then, after you've made sure that you had kept the denominator the same, you do the numerator plus numerator, or numerator minus numerator, depending on what the symbol is, either the plus or minus symbol. So let's take a look at that. Some examples. So first, 2/5 plus 1/5. 2 parts that are a fifth in size plus 1 part that's a fifth in size gives you 3 parts that are a fifth in size. Let's take a look over on the left at how that works. So we have 2 parts. Each of those parts are a fifth in size or 1/5 in size. And then to add to that, we combine whatever is next to the addition sign, which is 1/5, to that amount. And what we end up having is 2/5 plus 1/5 is 1, 2, 3 parts that are each 1/5 in size. So we keep the denominator the same and we write 3/5. Now if we had a subtraction symbol instead for that problem, then we would still start out with 2/5, right? 2 parts that are 1/5 in size. And then instead of adding or combining an extra 1/5, we take away 1 of the fifths. So when I take that away, what I'm left over with is 1 part that is 1/5 in size. So we kept the denominator of 5 the same, and then I did 2 minus 1, and I got 1. Now, let's take a look at what that would look like for more complicated problems where you start with the denominators being the same. So we have 4 3/8 plus 1 5/8. In this case, you keep the denominator of 8 the same. It represents part size. We need to keep that the same. So then I do whole number plus whole number. 4 plus 1 is 5. And then fraction plus fraction. 3/8 plus 5/8 is 8/8 because we have 3 plus 5 on the top, and then we keep the denominator of 8 on the bottom for part size. And so we have the whole numbers combined equal 5, and the fractions combined equal 8/8. Well, that's 5 and 8/8. And since 8/8 is the same as 1 whole, that's the same as 5 plus 1, which is 6. So our final answer there is the same as 6 whole. Now, if instead we were doing subtraction, it gets slightly more complicated, but don't be intimidated or scared by that idea. It really isn't that much more complicated. The only big problem we're dealing with for this problem is we can't do whole number minus whole number yet because the fraction on the left is smaller than the fraction on the right. So I can't do whole number minus whole number and then combine that with the fraction minus the fraction because this fraction is smaller. I need to make this fraction on the left larger than this fraction on the right. Well, think. What would I do? If you want to pause the video and think some more, that's fine. Alright, well, what you can do is you can actually borrow and then add over here what you're borrowing, and you turn what you borrow, which would be 1 whole, into a fraction that is equal in size to 1 whole, but that can make this fraction larger. So here's what that would look like. We take away 1 whole from the 4, but then we add it back up as 8/8. Because if you look on the left side, 1 whole is equal in amount to 8/8. Ta-da! So we can actually take away 1 whole here to add 8/8 here. Now why did we choose 8/8? Well, we needed the denominator to be 8 so that we could add it properly. And then the numerator had to be 8 because 8 divided by 8 gives you 1 whole back. So when I take away 1 whole from 4, that gets me 3. And when I add 8/8 to 3/8, 8 plus 3 is 11, and I keep the 8 on the bottom the same, then I get 11/8. 3/8 plus 8/8 is 11/8. So what I have there is that 4 and 3/8 is the same as 3 and 11/8. And then I bring down my 1 and 5/8, and then it becomes a really easy problem. 3 whole minus 1 whole is 2 whole, and 11/8 minus 5/8 is 6/8, and that's combined with the 2 whole through addition. But I didn't put a plus sign because I think that would make it a little bit more confusing. So we have 2 whole and 6/8. And then remember we talked about how if you can divide the top and bottom of a fraction by the same number, then you can simplify it even more. In this case, the greatest common factor is 2. It goes into both 6 and 8. And so you could divide the 6 by 2 and get 3 and the 8 by 2 and get 4. Then you don't forget to keep your whole number still there for your final answer. And you get that your answer of 2 and 6/8 is the same as 2 and 3/4. So the overall answer to this problem of 4 and 3/8 minus 1 and 5/8 is 2 and 6/8, which is the same in a simpler form as 2 and 3/4. Watch as I add 1/4 of a pizza to 3/4. See how I now have 4 parts that are each 1/4 in size, also known as 4/4 or 1 whole. So 3/4 plus 1/4 is equal to 1 whole. Now watch as I take away 1/4 from these 3/4. So each of these represent 1/4 of pizza, so 1, 2, 3/4. And now I am doing 3/4 minus 1/4. And what I am left with are 2 parts of a pizza that are each 1/4 in size. So that is 2/4 of a pizza, or as you may have noticed, 1/2 of the pizza. 1/2 is the simplified form of 2/4. But Mr. Dove, you may ask, how do you add and subtract if the denominators are actually different? Right? What if the denominators are known as uncommon denominators, meaning they have nothing in common in terms of being the same because they are different? So that actually isn't that hard to deal with. The goal is to get the denominators to eventually become the same. But you can't just do that willy-nilly. You have to be fair about things. The reason you need to get the denominators to become the same when you're adding or subtracting is so that the part size could be the same when you're adding or subtracting a certain number of parts. Right? That's fair. That makes it work to the best extent. So how would you do that? I'm going to reposition this, and we'll just talk about it one step at a time. So you could do this by finding the smallest number that all of your denominators go into. Sometimes that smallest number that all of them go into is called the least common multiple, or LCM. So for instance, 2 and 3, the smallest number they both go into is 6. The smallest number that 2 and 4 both go into is actually 4, because 2 goes into 4 and 4 goes into 4. So it depends on the numbers that you're dealing with. Then after you've found what they both go into, known as the least common multiple, if it's the smallest number that they both go into, then you multiply whatever you need to on both the top and bottom of each fraction so that your equivalent fractions each get the least common multiple as the new denominator. And I will show you what all of this looks like. So if you need to, you can always freeze the video or rewind it or slow me down in terms of speaking. But what I'm going through will be presented soon. So after you've found what the least common multiple is, and you've multiplied what you needed to on both the top and bottom of each fraction so that your equivalent fractions each have that least common multiple, then you do numerator plus numerator for addition, or numerator minus numerator for subtraction, depending on the symbol. Right? Either plus sign for addition or the minus sign for subtraction. And then you keep the denominator the same. So let's go through and see what that looks like. All right, we're going to take this one example at a time. And that should work out well. So let's say we had 5/6 plus 7/12. To figure out the least common multiple, which would be their denominator, so the least common denominator, that both 6 and 12 go into, I just list what 6 goes into and what 12 goes into, and then when I find what they both go into, I circle it. So for 6, I think 6, 12, 18 to start off, and then for 12, when I'm counting by 12s, 12, 24, 36 to start off. But actually, the second term in that pattern for 6 and the first term in that pattern for 12 is actually 12. So 6 and 12 both go into 12. So that is the LCM, or least common multiple. So now that I know that my denominators of 6 and 12 both go into 12, then we can turn this into an equivalent fraction, which is 12 as the denominator, and this into an equivalent fraction, which is 12 as the denominator. And for that one, it's the same fraction. All right, so to get this 5/6 into a fractional amount that is equivalent or equal, but has the denominator 12, I need to do the 6 times 2. And I got to be fair about it. Anything I multiply by the bottom, I have to do to the top as well, because times 2 over times 2 is the same as just multiplying by 1 whole, which is fair. So that's the reason why. So to get this denominator of 12, I do 6 times 2, and then I do the 5 times 2 as well. And so, as you see here, 5 times 2 is 10, 6 times 2 is 12. Now for 7/12, what you have there is that we've got a 7, and that's the numerator, and 12, and that's the denominator. To get the denominator of 12, you can just do times 1 for your denominator and do the same thing to the numerator of times 1. 7 times 1 is 7, and 12 times 1 is 12. So what we end up doing is we turn 5/6 into the equivalent fraction of 10/12 and 7/12 into the equivalent fraction of 7/12. And then it's easy. You just add top by top and keep the denominator the same because it represents part size. So if you'll join me over here on this left side of the screen, let's take a look. So what I'm doing is I'm building up the fraction of 10 parts that are each 1/12 in size. There we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 10/12. And then I'm going to add 7 parts that are each 1/12 in size to that. So 1, 2, 3, 4, 5, 6, 7. So now what we have there are 12/12, and then 13, 14, 15, 16, 17/12. And as I showed you earlier, you can turn that improper fraction into the mixed number of 1 and 5/12, right? 17/12 is the same as 12/12, which is 1 whole, plus 5/12. And you also see that over here, right? 12/12 is the same as 1 whole. And then we have that 1 whole next to the 5/12. So that is 1 and 5/12. So in other words, 5/6 plus 7/12 is the same as 10/12 plus 7/12, which is 17/12, or 1 and 5/12. Now, what would that look like as subtraction instead? Well, you still do the same opening steps of finding the least common multiple that 6 and 12 both go into, and then that becomes your new denominator. And then to get there, you have to do 6 times 2, and then do the same thing to the top. So you do the 5 times 2, and then you get 10/12. And then for your 7/12, you do times 1 times 1 to keep it the same. And now you have a common denominator. But this time, we have it as a subtraction problem. So I'll show you what that looks like on the left side of your screen. So we start out with 10/12, and then we take away 7 of those 12s. So we're taking away 1, 2, 3, 4, 5, 6, 7 of those parts that are each 1/12 in size. So 10 parts that are a 12th in size minus 7 parts that are a 12th in size. Well, 10 minus 7 gives you 3, so 3 parts that are each, you keep the denominator the same, so a 12th in size. So what you end up getting is 3/12. Now you could also simplify that down by dividing top and bottom by their greatest common factor, which is 3. 3 divided by 3 is 1, 12 divided by 3 is 4. And so that is also an equivalent fraction of its more simplified form of 1/4. So when you do 5/6 minus 7/12, That's the same as 10/12 minus 7/12, which is 3/12, or in simplified form, 1/4. Okay, now let's just look at problems that are slightly more complicated. Okay? Let's say that now we are dealing with 6 3/5 plus 3 3/4. So for this one, you could solve it just like you would with the mixed number problem that we talked about earlier, except you have to have common denominators, and right now they are uncommon denominators. 5 and 4 are not the same. So I make a list, either in my head or on paper, and I see what do 5 and 4 both go into. So 5 goes into 20, and 4 both goes in, and 4 goes into 20 as well. So they both go into 20, and that's the least number that they both go into through multiplication. So 20 is the least common multiple for both. Now I'll go through and talk about how you would list them, right? 5, 10, 15, 20 for 5, and then you could keep on going if you needed to. And then for 4, 4, 8, 12, 16, and 20. So the number they had in common so far was 20. And that's the smallest number they both had in common. So we know that our denominator for both of the fractional parts of these mixed numbers needs to be 20. So what do? Well, I have to multiply this by 4 to get 20, and then I got to do the same thing at the top as I did at the bottom. So we have 6 whole, and then 3 times 4 over 5 times 4. So that gets us 6 and 12 twentieths. And then over here, to get to 20, I have to multiply the bottom of 4 by 5, and so I have to do the same thing to the top and multiply that by 5. And so we have 3 whole, and then 3 times 5 over 4 times 5. So when you do that next step for both, you end up getting 6 and 12 twentieths plus 3 and 15 twentieths. And then you do whole number plus whole number. 6 plus 3 is 9. And fraction plus fraction. 12 twentieths plus 15 twentieths would be 27 parts that are each 1/20th in size. Remember, you keep the denominator the same once it is the same. So we have 9 and 27 twentieths. And then because 27 twentieths is an improper fraction that can be turned into the mixed number of 1 whole and 7 twentieths, right? 20 goes into 27 1 whole time, and there's 7 out of 20 left over. Then we can add that 1 and 7 twentieths to the 9, and you get 10 and 7 twentieths. So 6 and 3/5 plus 3 and 3/4 is the same as 6 and 12 twentieths plus 3 and 15 twentieths, which is 9 and 27 twentieths, which is 10 and 7 twentieths. Okay, if you need to see that some more, you can pause the video. Otherwise, in a few seconds, I'll move this up so you can see the extent of that other problem. Okay. Now what if we were doing subtraction? Well, you still know that the least common multiple for these denominators, also known as the least common denominator, would be 20. So both the 5 and 4 go into 20, as we talked about earlier. So to get there, I have to do times 4 to this 5 to get 20, and then times 4 to the 3, same thing to the top that I do the bottom of the fraction. And so this 6 and 3/5 is the same as 6 and 12 twentieths. And then on this side, to get to that common denominator of 20, I have to do the 4 times 5, and then whatever I did at the bottom, I have to do at the top. So I have to do that 3 times 5 as well. And so what we get there is 3 whole and 15/20. So we have 6 and 12/20 minus 3 and 15/20. Now if the fraction on the left was larger than the fraction on the right, then we could do whole number minus whole number and fraction minus fraction. But that's not the case. Because this fraction is smaller, I need to make it larger so that I can do whole number minus whole number and fraction minus fraction. Well, remember earlier how we said you can take away one whole and then add it back to your number as a fraction that is equal to one whole and has the denominator that you need. So in this case, we can take one whole away from 6, which is 5, and then we would add that one whole back as a fraction that could be added to 12/20. So the fraction would need a denominator of 20, and then a numerator of 20 as well. And so we are dealing with adding 20/20 to 12/20. We keep the denominator of 20 so we can add it to the 12/20, and then the numerator has to be 20 so that the value of this is equal to one whole. So we took away one whole and added it back as 20/20. So 6 minus 1 whole is 5, and 12/20 plus 20/20 is 32/20, right? 12 plus 20 is 32, and then you keep the denominator the same because it represents part size. Now we can do 5 and 32/20 minus 3 and 15/20 real easily. 5 minus 3 is 2, and 32/20 minus 15/20 is 17/20, because 32 minus 15 is 17. If you need to do that on the side, that's perfectly okay. And then you keep the denominator of 20. So your final answer, because it can't be simplified, is 2 and 17/20 as a mixed number. 2 and 17/20. Now let's try 3/4 plus 3/8. So you would need to turn 3/4 into 6/8 by doing times 2. So you split that in 2, and that in 2. And you would get that 3/4 is 6/8. Then plus 1, 2, 3/8, and you get your answer of 1 whole and 1/8. This is because if this were split into 6/8 and then you have that plus 1, 2, 3/8, then you would get 9/8, and 9/8 is the same as 8/8 plus 1/8. And then if you had 3/4 minus 3/8, then what you would do is you would turn your 3/4 into 6/8 so that you had the common denominator by doing times 2 times 2 at the top. So I actually cut these up a little bit more. So now they represent 6/8, and then if we're doing that minus 3/8, then minus means we take away. So 1, 2, 3 of those 8. And then what we're left with are 1, 2, 3 parts that are each 1/8 in size. So our final answer is 3/8. So 3/4 minus 3/8 equals 6/8 minus 3/8 equals the fraction of 3/8. Hey, welcome back. So, what's the pizza order for everybody? All right, I think we can make that happen overall. We'll see what we can do, right, kids? I guess. It's time to talk about how do you multiply the numbers that we've talked about. So, here's the good news for multiplication. Since you can expand or shrink numbers by any amount when you multiply, the part sizes or denominators do not have to be the same size. Hooray! So, in other words, you don't need to have common denominators, because at the end of the day for multiplication, it's as easy as numerator times numerator and then denominator times denominator once you have everything in fraction form. Just turn all the numbers into fractions at first, and then you multiply your numerators together, and then you multiply your denominators together. At the end, you can turn your answer into a simplified form and a mixed number if desired by you or your teacher. So let's take a look at what that would look like overall. So 5/7 times 7/10. Just do top times top and bottom times bottom. Voila! Right? 5 times 7 is 35. 7 times 10 is 70. The reason you can do this, like I had mentioned earlier, is because you can expand or shrink something by any amount, like blowing up or sucking in air from a balloon. Okay? So for this, 5 times 7 is 35. 7 times 10 is 70. And then if you need to simplify, you would do so. So the greatest common factor for both these is actually 35, but I don't expect you to know that off the top of your head. So you could divide both top and bottom by 35 and you would get 1 over 2 or 1/2. But for most of you, if you know your math facts, you know that 35 and 70 can both be divided by 7 to get the equivalent fraction of 5/10. And then the 5 and the 10 can both be divided by 5 to get the equivalent fraction of 1/2. So even though your original answer might be 35/70, your final simplified answer could be 1/2. So in other words, on the left side, that is equal to 5/10, which is equal to 35/70. Okay? Now you can also simplify from top to bottom for some fractions some of the time in multiplication. Then there's also a process that I call simplifying diagonally or cross-simplifying, where you're simplifying the numerator of one part and the denominator of another fraction. And even though it gets you the right final answer, you're changing the fractions in a way that technically changes their amounts in the problem. So just keep that in mind. But the way that works if you simplify diagonally, or what I call cross-simplifying, is you divide the top of one fraction and the bottom of another fraction by the same number. In this case, 5 and 10 can both be divided by 5. And 5 divided by 5 is 1, and 10 divided by 5 is 2. And then in this case, we have a 7 and a 7 here, and they can both be divided by 7. So 7 divided by 7 is 1, and 7 divided by 7 up here is 1. And so now you have this new problem with new numbers that are not equal in terms of their amount to the old numbers, but are equal in terms of the final answer that you get. So 1 times 1 is 1, and 1 times 2 is 2, and so you still get the same final answer of 1/2, and that just makes it easier. Now, if you are dealing with a problem where you have mixed numbers or even whole numbers, then you would need to turn them into fractions first. Remember, there was a part in the video where I talked about how you would turn mixed numbers into fractions. And then after you turn them into fractions, then you can do simplifying or cross-simplifying if possible, and then top times top and bottom times bottom. So what we have here is 4 4/5 times 1 7/8. You can turn 4 whole into 20/5, and you do that so that you can add it to the 4/5. That's why you keep the denominator of 5 the same, so you can do that addition the correct way. And the reason that new numerator is 20 is because 20 divided by 5 gives you 4 whole back. So 4 4/5 is the same as 20/5 plus 4/5, which is 24/5. Now we have successfully turned this mixed number into an improper fraction. Then over here we have 1 7/8. So we turn the 1 whole into 8/8 so that we can add it to the 7/8. You want to keep the denominator of 8 the same. And then the new numerator for this fraction over here is 8, so that we can have 8 divided by 8 gives you 1 whole back. And then that 8/8 plus 7/8 is 15/8. So now that 1 7/8 has been turned into 15/8. Then you could do 24 times 15 up top, and then 5 times 8 on the bottom. But you also could simplify if possible, right, for these fractions, but it's not possible because the 24/5, there's nothing that goes into both 24 and 5 except for 1. And for the 15 and 8, there's nothing that goes into 15 and 8 except for 1. But I'm just throwing that out there. That is a possibility for other fractions. But to make this easier on yourself, you can cross simplify just like we did previously. So the 24 and the 8, you can divide both of those by 8. 24 divided by 8 is 3. 8 divided by 8 is 1. And then the 5 and the 15 both can be divided by 5. So 15 divided by 5 is 3, and 5 divided by 5 is 1. And then you end up with completely different fractions from the original. Okay, these are not equivalent fractions to what they were originally, but the final answer that you get from here is the same as if you did it the top way of 24 times 15 and then 5 times 8 and then had to simplify a bunch. So we have 3 times 3, which is 9 for our new numerator, and then 1 times 1, which is 1 for our new denominator. So we have 9 over 1, and 9 whole over 1 whole is just 9 whole overall, right? 9 divided by 1 is 9 whole. So our final answer is 9. So 4 4/5 times 1 7/8 is equal to 9 after we turn these into fractions and then simplified or cross-simplified in this case, if possible, and then found out what the answer was and turned it into, in this case, a whole number, but some of your other answers would be mixed numbers.
Now, what if I were to do 1/3 of 3/4, also known as 1/3 times 3/4? So 1/3 times 3/4 would be 3/12. And when you simplify 3/12 by dividing the top and the bottom by 3, what you get is 1/4. So in other words, when I do 1/3 times 3/4, I get 1/4. Let's see how that plays out. So I have 3/4 here, and I'm taking out all these so that what is left over is just one of those 3 parts, right? I took 1/3 out of the 3/4. And what I'm left with is one part that is 1/4 in size. So that is 1/4.
And finally, let's talk about how do you divide with fractions and mixed numbers overall. Well, since you can shrink or expand numbers by any amount, the good news, just like with multiplication, is that when you divide, the part sizes, our denominators, do not have to be the same size. So you can keep the denominators different. Totally okay. There is one extra step though. Just a little extra step that you need to remember. So when you divide, you still turn all the numbers into fractions, just like with multiplying. But then you need to transform dividing by the right fraction, meaning the fraction on the right side. If you ever forget your left from your right, you can make an L with your left hand, but your right hand can't make an L. So the fraction on the right side, you transform dividing by that fraction into the opposite of dividing, which is multiplying, and the opposite of that right fraction, which is its flipped over form, which is called the reciprocal. So if the fraction on your right was, let's say, 1/2, then dividing by 1/2 is the same as multiplying by 2/1, where 2/1 represents the flipped form or reciprocal of 1/2 or 1/2. And we'll show what that looks like in just a little bit. Then, after you've turned it from a division into a multiplication problem, you'd multiply your numerators together, and then you multiply your denominators together, and then at the end you could turn your answer into a simplified form and a mixed number if possible. Just like with multiplication. Okay. So, let's take a look at the examples that we have. 4/10 divided by 4/5. So, I'm going to turn my divided by 4/5 into times 5/4. So my problem changes from 4/10 divided by 4/5 into 4/10 multiplied by the flip form of that, which is 5/4. Remember, the flip form is also called the reciprocal. Okay? So we have 4/10 times 5/4 now. And we can do 4 times 5 is 20, and 10 times 4 is 40. And then if you were able to really think it through, the GCF, or greatest common factor, in both 20 and 40 is actually 20. So when you divide 20 by 20, you get 1, and 40 by 20, you get 2. So 1/2 is a simplified form. But for most of you, knowing your math facts, you could divide 20 and 40 by 10. 20 divided by 10 is 2. 40 divided by 10 is 4. And then you could divide by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. Now you may have also noticed that for this particular problem, you could also get 1/2 if you just divided the top by the top and the bottom by the bottom at the beginning. And if you've already noticed that, that's pretty incredible thinking on your part. So yes, 4 divided by 4 is 1, and 10 divided by 5 is 2. So if you divide top by top and bottom by bottom, you would also get the final answer right for this particular problem. However, many of the problems that you deal with are not going to be that easy and won't have whole number answers for your numerator and your denominator if you divide top by top and bottom by bottom. That's why I'm teaching you the strategy of turning dividing by a fraction into multiplying by its flipped form. Okay? So let's look at that problem again. So we have 4/10 divided by 4/5. And that is going to be turned into 4/10 times 5/4, right? Opposite of division is multiplication. Opposite of 4/5 is 5/4. Now, you can simplify from top to bottom or diagonally, what I call cross-simplifying, if that's a possibility. So cross-simplifying actually is a possibility here, but I want to show you just normal simplifying and how that would work for this problem. So I'm going to simplify this fraction of 4/10. 4 and 10 can both be divided by 2, and then I would get 2/5 as a simpler form. real quickly, I'm just going to remind you of how that would work. So on the left side of your screen, you see how I have 4/10, and then on the right side of the screen, you see how 2/5 is equal in overall amount to 4/10. It's just written in a simpler form. So I turn that into 2/5, and then I multiply 2 times 5, which is 10, and 5 times 4, which is 20. And so I get 10/20, and then I simplify that again. 10 divided by 10 is 1. 20 divided by 10 is 2, and then it's in its simplest form. Okay? All right, now what if I started with problems where I had a mixed number? Well, for these sorts of problems, you can also simplify at the beginning. So, if possible, right, then you could simplify 2 and 4/8. 4 and 8 can both be divided by 4. And I can simplify 1 and 3/6. 3 and 6 can both be divided by 3. So when I do that, 2 and 4/8, right, 4 divided by 4 turns into 1, 8 divided by 4 turns into 2. So now I have 2 and 1/2. And then 1 and 3/6, 3 can be divided by 3, and 6 can also be divided by 3. 3 divided by 3 is 1, 6 divided by 3 is 2, so I have 1 and 1/2. So now that'll make it easier to work with later on. So I'm going to turn these both into fractions, and then I will solve the problem. So 2 and 1/2. So 2 is the same as 4/2. I turn that into 4/2 so I can add it to 1/2. 4/2 plus 1/2 is 5/2. And then I have 1 and 1/2, and I turn 1 whole into 2/2 so that I can add it to 1/2. And 2/2 plus 1/2 is 3/2. So now this complicated problem has been turned into something a little bit easier to work with. 5/2 divided by 3/2. And then I just turn dividing by 3/2 into multiplying by its reciprocal or flipped form of 2/3, right? 3 over 2 got turned into 2 over 3, and then the division sign got turned into a multiplication sign. And so now I have 5/2 times 2/3. Now remember, you could cross simplify this. You could do the 2 and the 2 both divided by 2. But for this one, we're going to finish it up by doing 5 times 2 gives you 10. 2 times 3 gives you 6. So we have 10/6. Both of those are even numbers, so they can be divided by 2. 10 divided by 2 is 5. 6 divided by 2 is 3. That's also the simplest form because 2 happens to be the GCF, or greatest common factor, that goes into both 10 and 6. So what you end up getting is 5/3. And then remember, you can turn 5/3 into its mixed number form, right? 3 goes into 5 one whole time, which is 3/3. And then there's 2/3 left over. So 5/3 is the same as 1 and 2/3. Nice. I've got a little surprise for you all at the end of this video.
Let's see what happens when we divide 3/4 by 2. So 3/4 divided by 2 is the same as 3/4 divided by 2 once, or 2 over 1. And that's the same as 3/4 times the flip form or reciprocal, 2 over 1, which is 1 over 2, or 1/2. So in other words, 3/4 divided by 2 once equals 3/4 times 1/2. And 3/4 times 1/2, 3 times 1 is 3, 4 times 2 is 8. So 3/4 times 1/2 is 3/8. So now let's see how that works. So we have 3/4 here, and we're dividing this into 2 parts. That's the same as multiplying by 1/2. So when I split this up into 2 parts, one of those parts is 1, 2, 3 parts of pizza that are each 1/8 in size. So we get the answer of 3/8, where 3 is the numerator and 8 is the denominator.
Now it's time to put on some snow gear and deliver all this pizza to Popsicle's family.